Hello, welcome to my channel Deep Learning Biology. In this video, I am going to teach you more about the concepts of Gibbs free energy. So, in previous class, we have discussed a lot about Gibbs free energy. In this video, I am also going to teach you few other concepts which I have not taught you related to Gibbs free energy. Now here let us suppose you are going to have a reaction A, it is being converted into B. Now if you want to calculate whether this reaction is possible or not, whether A can be converted into B, this reaction is going to proceed in forward direction or not, this you can easily predict if you know the concept of Gibbs free energy. Now try to see here. Okay, let's suppose you are going to plot the graph, okay, in between time and the reaction, okay, how the reaction is going to proceed. And let's suppose here you are going to show the energy, okay, so this is Gibbs free energy of the reactant. So this is the point where your reactant are going to have the energy. And let us suppose you are going to see the formation of product. Okay, so here keep in mind there is a barrier that is known as activation energy barrier. Okay, so here let us suppose you are going to have the energy of the product. Okay, now here if you see, so your reactant, they are going to have some energy. Okay, so this is the point where your reactant are going to have, and this is the point your product is going to have energy. Now this point, okay, it is your from here to here. Okay, what you need, this is your activation energy. Okay, now this barrier has to be crossed, otherwise this reaction is not going to proceed. But here if you see the energy, the Gibbs free energy of the reactant and Gibbs free energy of the product, and if you see this is going to be the change in Gibbs free energy. So here this is delta G. Now in this case what you are going to see, the product is going to have less energy, the reactant they are going to have more energy. So here what you are going to see, energy will be released. So here in this process what you are going to see, delta G is equal to negative. Okay, now you can have another situation. So if you plot the graph like this, okay, same way here you are going to have time. Okay, and let's suppose you are going to Gibbs free energy. Okay, same way here if you are going to have, this is your energy of the reactant. Okay, then you are going to have this activation energy barrier, and this is the product. So here this is your reactant, this is your product. Okay, now here you see this point, it will be delta G. Okay, here your product is going to have more free energy in comparison to the reactant. So here the value of delta G will be positive. Okay, so here hopefully you have seen the graph. Okay, and hopefully you are able to understand this. Now if you remember, in my previous class I have told you, if the value of delta G is equal to negative, means the reaction is exergonic. Okay, and here you are going to see the reaction is going to be endergonic. Okay, exergonic reaction, in exergonic reaction what we are going to see, we are going to see a release of energy. Okay, and in case of endergonic reaction you have to provide the energy. Okay, your product is going to have more energy, so you must supply the energy. And here hopefully you remember, in case of exergonic reaction, when you are going to have this value delta G is equal to negative, in that situation your reaction is spontaneous. Okay, means the reaction is going to proceed towards the product formation. and here this reaction is not going to be spontaneous unless and until you are going to provide the energy. Okay. Now here in your chemistry class you must have learned about one relation. Okay, change in Gibbs free energy, delta G is equal to delta H minus T delta S. Okay. Now here if you see delta G, it is equal to change in free energy. Okay. Now delta H, here it stands for change in enthalpy, the heat content. Here T is the temperature, and generally we represent the absolute temperature. Okay, and delta S, it is going to represent the change in entropy. Okay, hopefully you understand what is entropy. Entropy is the randomness. Now in your chemistry class you must have learned H is equal to E plus PV. Okay, H here is enthalpy, is equal to E stands for energy. Okay, PV, okay, pressure, volume, work. If you expand this, delta H is equal to delta E plus P delta V plus V delta P. Okay, now I have told you that in cell, okay, you are not going to see any change in the volume. Delta V is equal to 0. Okay, same way delta V change in pressure is also 0. So here in cellular condition what you are going to see, change in enthalpy is equal to change in energy. Okay, this. Now here I have to tell you that you have seen that in case when the value of delta G is equal to negative, the reaction is spontaneous. Okay, and here if the value of delta G is equal to positive, okay, the reaction is non spontaneous. Now here if you remember this relation I have told you now, delta G is equal to delta H minus T delta S. Okay, now think about this relation. Okay, so here if in any reaction, let's suppose A is being converted into B. Okay, if your delta G value finally it becomes negative, then the reaction will proceed in the forward direction, otherwise not. Okay, now try to see here this value of delta G, it depends on the value of delta H, it depends on the value of T, it depends on the value of delta S. Now here if you see the value of delta H, okay, change in enthalpy, it can be positive, it can be negative. Okay, same way the value of delta S, okay, it can be positive, it can be negative. Same way your temperature, it can be positive, it can be negative. Okay, now here if you see, let us suppose you are going to have this value delta H is equal to positive. Okay, means your reaction is endothermic. Okay, here let us take this example, and here also delta S value is also positive. Okay, so if you are going to have such situation in which you are going to have delta H value positive, okay, if you are going to have this relation delta G is equal to, let's suppose delta H value is positive, okay, and minus, okay, you are going to put the value of the temperature, and here also the value of delta S is equal to positive. Okay, now you have to see what is the net value of delta G. Okay, now here I just want to give you the example. Let's suppose hypothetically, okay, this value delta H is equal to 10, okay, and we are just taking temperature as 2, okay, and this delta S value as 3. Okay, so this is delta S, we are putting 3, 2, 10. So if you solve this, 10 minus 6, it will come out 4. So here you see the reaction is having delta H value positive. Okay, the reaction is endothermic. Delta S value positive. Okay, so here what you are going to see, the change in entropy is positive, and if you are going to have value this 10 minus 6, it is equal to 4. So here this reaction is going to have positive value, means the reaction is going to be non-spontaneous. Okay, now you can have another situation. Okay, let us see here you increase the temperature. Okay, so here if you increase the temperature, okay, earlier you were having 2, okay, let's you have now 50. Okay, so if you are going to put this 10 minus 50 into 3, okay, it will come out 10 minus 150, okay, it will come out minus 140. Okay, now try to see here the same reaction. Okay, it is going to be, so here if you solve, delta G value is equal to negative. So the same reaction which was earlier non-spontaneous, it can be spontaneous when you have increased the temperature. Okay, so here if you see, just by changing the temperature, okay, what you are going to see, that this reaction has now become spontaneous. Okay, so these parameters are going to tell you how you can proceed any reaction in the forward direction. Hopefully you are getting my point. Okay, so here we have seen, if value of delta H is equal to positive and delta S value is equal to positive, okay, and such type of reaction, okay, they can be spontaneous, they will be spontaneous, okay, at higher temperature. Okay, now here I just want to give you one example, is the melting of ice. Okay, so here if you see, if you are going to have solid ice, okay, okay, now it will melt into water. Okay, okay, so here what you are going to see, entropy is going to increase and you are providing the heat. Okay, so here delta H is positive, delta S is positive, and what you are going to see, this melting of ice, okay, it will be it is going to occur spontaneously at higher temperature. Now you can have another situation. Let's suppose you are going to have delta H value is negative and delta S value is also negative. Okay, so if you are going to put this value, delta G is equal to, our relation is delta G is equal to delta H minus T delta S, and in this example what we are going to see, delta S value negative and delta H value negative. Okay, so this is, let's suppose, negative. Okay, and let's suppose it is, now your T delta S will be positive. Okay, now here you have to see, okay, in which condition the reaction is going to have delta G value negative. Okay, now here if you see this delta G value, it can be negative when this delta H value is more negative. Okay, now here it can happen when this T, okay, it is less. So here you can easily calculate this reaction, if it is going to occur at low temperature. Okay, in that situation what we are going to have, this value will be less. Okay, let's suppose this is delta H is minus 50 and here the temperature is just 2, okay, and delta S 3, okay, thus you see it will come out, okay, minus, okay, here 2, and here we have to take delta S negative, it is minus 3. Okay, so minus 50, okay, it will be plus 6, okay, it will come out minus 44. Okay, so here you can see in this reaction that the value of delta G is equal to negative when the temperature is less. Okay, so this reaction is going to be spontaneous when the temperature is less. Condition is delta H is negative and the value of delta S is negative. Now the same reaction, okay, at higher temperature, okay, so when we are going to have much higher temperature, let's you take this, let's suppose this is minus 50, okay, if you increase the temperature, let's you increase it to minus 50, okay, minus 50 into minus 3, okay, so here it will come out minus 50 plus 150, and if you solve out it will come out plus 100. Okay, so in that situation the reaction is going to have delta G value positive. In that situation reaction will be non-spontaneous. So here you have to play with this equation, okay, and you have to see what is the net value of delta G. Okay, now here I am going to discuss you another situation. Okay, let's suppose you are going to have delta H value negative and delta S value positive. Okay, now try to see here. In this situation, if you see the relation is delta G is equal to delta H minus T delta S. Okay, so here your delta S value is positive, okay, and delta H value is negative, so it will be negative. Let's take any minus 5. Okay, 1 minute please. Okay, this is minus 5 minus T delta S. Okay, so here this is T. Okay, let's suppose we are going to take 2. Delta S is we are going to take positive value. Okay, so if you see minus 5 minus 6, it will come out, okay, minus 11. Okay, so here what you are going to see in such reaction where you are going to have delta H negative and delta S positive, means entropy is going to increase. Okay, so in such type of reaction what you are going to see, that such type of reaction they are always spontaneous. Okay, so just you have to see what is the net value of delta G. So hopefully you have understood this concept. Here I just want to make you clear in your mind. Okay, spontaneous, what does means, whether the reaction is going to proceed in forward direction or not. Okay, so here keep in mind, spontaneity does not means the rate of reaction. Okay, so the reaction may occur slowly, okay, or quickly. So here just we are going to calculate whether the reaction is going to proceed in forward direction or not. Now here I also want to tell you, so here if you see delta G is equal to delta H minus T delta S. Okay, let us suppose this value and this value is equal. Okay, delta H is equal to 5, and if you calculate this it also comes 5. So here what you are going to see, 5 minus 5 is equal to 0. Now think here, when you are going to have delta G value 0, okay, in what condition the reaction is, okay, always remember when change in Gibbs free energy is 0, the reaction is at equilibrium. Okay, so hopefully you are going to remember this. Okay, now here if you must keep in mind, when the value of delta G is equal to negative, the reaction is exergonic. Okay, exergonic, and exergonic they are going to be spontaneous. Okay, means the reaction is going to proceed in forward direction. If the value of delta G is equal to positive, okay, the reaction is endergonic. Okay, they require input of energy. Okay, and they are non-spontaneous. Okay, they are not going to occur on its own. Okay, and also keep in mind, when the value of delta H is equal to positive, okay, so this is endothermic reaction. and if you are going to have this delta H value is equal to negative, the reaction is exothermic reaction. Okay, so hopefully you have understood this concept.